We're about to see repair of a turbine blade like this one and a compressor blade by directed energy deposition of Inconel 625 material. Directed energy deposition for repair of aircraft engine blades like this turbine blade. It involves precision optical measurement and custom programming, different program for every part. I'm Pete Zielinski with Additive Manufacturing Media. I am at Optomec's facility in Clover, South Carolina. This is where Huffman laser cladding machines for aircraft engine blade repair are produced. To repair a blade like this, the first step is optical measurement, establishing the profile of this blade. Every worn blade is going to wear in a different way, create essentially a unique part. That optical measurement is used to first automatically create the tool paths that will be used to repair this blade through directed energy deposition. Determining just the deposition tool path based on the optically measured cross-section isn't enough, because that varying thickness at every different position along the blade determines the area in which the heat of the laser goes into. So the AutoClad software that oversees the process on this Huffman machine, it's also determining feed rate and laser power, which are varying in real time as the thickness of the blade changes, as the deposition path advances. The compressor blade that we're seeing welded has a fully longitudinal deposition path all the way along the edge of the blade. But this turbine blade has a different path. Around the perimeter is a longitudinal deposition, but then there is more of a stitching path, parallel raster segments in parallel with the thickness of the blade. One consequence of that is shorter grains in the microstructure of the material and potentially better fatigue performance over time as a result of that microstructural form. This may not be essential for something like repairing the tip, but in a more critical repair, like repairing the leading edge of a blade like this, those microstructural properties might be important.